Hello YouTube, Ron this side. So in today's video, we will be learning about secret store CSI driver. So there are some scenarios where we have to inject our secrets, or you can say some confidential data in our applications or within the pods. So although Kubernetes has config map and secrets, but they cannot be useful because they are not very secure, as they are just base64 encoded format and anyone can decode them. So to solve this issue, we have some other operators like secret store CSI driver, where we can inject our uh, confidential data like API keys, passwords, and other stuff as a volume, and those volume can be used by our pods. So in this video, we will be learning about like how we can use secrets store CSI driver within our AWS EKS cluster, where we will be using a service known as AWS Secret Manager, where we are just storing our one of the variable or our one of the secret, and that will be utilized by our pod. So first, let us understand what is secret store CSI driver. So the secret store CSI driver allows Kubernetes to mount multiple secrets, keys, and certificates stored in enterprise-grade external secret stores in the pod as a volume. Once the volume is attached, the data in it is mounted into the container's file system, and hence our container can easily use those variables or those secrets, and they can complete the flow. So to install CSI driver, first we have to use or add the repository, the Helm repository of secret source CSI driver. Then after that, we also have to provide the AWS secrets and configuration provider using this command. After that, we will be validating that whatever we have installed is correctly installed or not. So after this, we will be creating a OIDC identity provider for our cluster so that our uh, EKS cluster can easily communicate with the AWS services which we will be using in the demo. So suppose secret manager. After this, we will be creating a policy where we are just mentioning the actions, what actions we can provide, we can do on the secret manager resource, and we will be specifying the particular resource where we have stored our secret. After creating the policy, we will be creating a role where we will be attached that policy, and within the policy, we will be creating within the role, we will be creating a trust relationship JSON file where we are providing the OIDC providers so that my role can easily synchronize with my role will be the one who will be act as a mediator between our Kubernetes cluster and the AWS service. After creating the role, the policy, and my trust relationship, which has OIDC link, then we will be appending the one annotation in the service account, which we are using for following, which we are using for creating this demo. One important thing, these are the flags which we are setting when we are installing the secret CSI secret store. So here it is nothing but we are mentioning that the synchronization of our secret is enabled. Then if we are having secret rotation, like where we are like rotating or modifying our secret, so that should pick up uh, correctly and accurately. And along with this, we are also having a poll of 15-second interval where every 15 second our operator will communicate with the secret manager where it will check if we have a new secret available or not. If yes, it will do the same, like it will do the sync, and if it is not, then it will let it be as it is. So yeah, these are the instructions and commands I will be using throughout the demo. And apart from demo, let us also take or explain, learn what are the files, YAML manifest file I'm using. So let's go one by one. So this is our deployment.yaml file. Okay, so first let's just go with service account. So this is the service account YAML where the kind is service account and this is the name, and everything is in my default namespace. After this, let us see what is secret provider class.yaml, because it is the one which is having uh, the main component where it is allowing our pod to mount the secret as value. So here, this is the API version for our custom operator. Then this is the kind, which is secret provider class. This is the name we have given, and this is the object, like secret store. So secret store object name simplify that the name which I have created inside my secret manager, and object type is also we have given a secret manager. So this is the object name which is secret store. Let us see. So here you can see this is the secret name which is secret store, and the same name I have provided here. After that, we have JMS path, which is equivalent to JSON path, which can also include XML hierarchy as well. So this is the type, which you can also see or learn more when you will be exploring the GitHub repository or the official documentation for a secret provider class. Apart from this, means inside this we have given a path which is username. So this is the variable name which we have provided inside our secret manager, aka secret store here. So this is the secret key, which is username, and we have created an object alias, which means that the same thing will be annotated as DB username for our application, because in our application we are not using username as a variable, we are using DB username. Okay, so these are the parameters which we are passing inside this, and here we have to provide the value. So this is secret objects where in the secret name we have to provide our secret store. Then type is opaque, and the data is DB username, which we have passed, provided here, and the key value is DB username 01. So here, DB username is the variable for our object name, and the key is DB username 01. So let me explain you where is DB username 1 is. So this is our deployment.yaml, and it is a simple deployment.yaml, where we are creating an service account as well as using Nginx. The main part here is first is annotations, where we have mentioned that rotation is true and rotation pole interval is 5 seconds. Although inside the flags in the README, I have provided it 15 seconds, but it will override that value and it will use this one, which we have provided inside deployment.yaml. After this, we also have to provide the service account name because it is a part of our OIDC. So service account name should be there. After this, this is the volume mounts. So here you can see that we are, okay, so let's go with this volume block first. So this is the name for volume, and the driver is secrets-store. Then it's a read-only mode we are giving it, and secret provider class name is deployment SPC create secret. So this value is referring from this thing, secret provider class.yaml, where we have given this name. Okay, let me uh, duplicate the tab so that I can explain it uh, across. So, okay, so first go to the deployment.yaml and inside volumes block. This is the secret provider class name, which we are referring from this one. And after this, here we are mounting the volumes. So this is the name which is which is referring from the volume block. Then this is the mount path where all the our volume will be stored, and the read only mode is true here. And now this is the environment block where we are passing the environment variables for our pod, which is nginx here. And from secret key reference, uh, as we are mounting a volume, so this is the format of referring the secret. And here we are giving the name as secret store, and the key is db username 01. So if I go to my secret provider class YAML, so here you can see that this is the secret name, which is secret store, and the key value is db underscore username underscore 01. And the value of db underscore username underscore 1 will be get from db username, and db username will get its value from username where we have provided the path. So this is how we will be like doing this demo, where we are injecting our username as a secret for our application. I hope I was able to make some sense here, like what we are trying to do. Let me reiterate in short. So first we will be installing all the drivers and all the operators and all the CRDs for our secret store CSI driver. After this, we will be creating an identity provider for our Kubernetes cluster, and attaching that OIDC to our role, which we will be creating. And the role should has enough permissions, or it should has the policy to access the secrets which we have stored in our secret manager. After creating the role and policy and syncing them with our OIDC, we are just appending our annotations of our OIDC in our service account. And then we just have to deploy these YAML manifest file, and then we can check the things. Okay, so I guess we can start with the demo. So this is so I'm using AWS EKS Cluster, and let us check the nodes are healthy or not. So I can see that they're up and healthy, and I'm using for the node of cluster, and the version is 1.30. So let's first install the CSI driver in the cluster. So for that, we just have to copy this thing and just paste it. Just make sure that you have Helm already installed. So for me, this already exists, so it has a script there. After that, let us install this commands as well. So everything will be installed inside my kube system namespace, because mostly all the static pods and all other important stuff is installed inside kube system namespace. So I'm just going with the flow. So we have installed our secret driver. Let us install AWS secrets and configuration provider as well. Okay, so it is also installed. Now let us check if whatever we have installed right now is correctly installed or working or not. So here we are just checking the daemon set, which has the label CSI secrets store provider AWS. As we have four nodes, four worker nodes, so as daemon set is a pod, is a special pod which get installed in all the nodes. So that's why we have four here. After this, let us also check daemon set for this label as well. So here also it is up and running. So we are good with this. Okay, so now let us create an IAM OIDC identity provider for our cluster. So this is the command for that. So it has created and yeah, it is done. Okay, so now what we have to do is first we have to create a policy. So let us create a policy and first create a file like policy.json. Okay, and now just copy this thing and save it and get exit from this. And now I will be just copy this command where which simply state that we are creating a policy and the name we are giving is AWS EKS secret CSI demo, and the policy document is policy.json, which we just created. Okay, so I think yeah, it has created the policy. Now creating a role and appending the above trust policy. Okay, so I think I also have to use this. First, let me copy the name. So this is the name. But here, when you will be performing the same thing, you have to please keep make note of this. That let me show you. So you just have to make sure that you should remove this ID because it is specifically for each YDC provider. So it will be different from for you. And let us see where you will get this. So you will get this ID inside your EKS, and you just have to select your cluster. In my case, it is secret CSI cluster. Then inside OpenID connect provided URL, you just have to copy this ID and paste it here. And same thing, like same ID, I have to provide it here as well. Otherwise, it will not work, and your EKS cluster cannot be like cannot communicate with your AWS services. Okay, so we have created the trust relationship JSON file as well. Okay, now let us go here. Okay, so now what we have to do is we have to create a role and appending this trust policy with that role. Let me clear out the window and now just paste this. Okay, I think yeah, our role is created and our trust relationship is also attached to the role. Now we have to attach the role with the policy. Okay, so okay, my policy is also attached. Now we have to append our annotations to our service account. So first we have to create our service account YAML inside our cluster. Nano SA YAML. Then paste this and let's get out from here. Let's exit from that. Now apply this YAML manifest file. Okay, so let us check kubectl guest SA, and here we can see that my service account is created and it is visible as well. So now what we have to do, we just have to use we have to annotate our add the annotation of our OIDC to our service account. We just have to copy this and we are annotating our service account with our OIDC. Okay, so I think it is annotated. Okay, so we are done with the steps. Now we just have to uh, create this file and copy its content there. So we can directly copy this, paste it here, save it, and get exit from this. And our deployment.yaml, which is nothing but it's just a Nginx application. Nano deployment.yaml and save it. Okay. Now we just have to apply these manifest file one by one. Okay, so they are created. Let us check the pods. Okay, so our pod is running. Let us check by going inside it. kubectl exec-it. This is the pod ID. Hyphen n is not required, I guess. Then bin dash dash. Okay, I have wrote it twice. Okay, so now we are inside our pod. So let me show you what is the value I have provided in my secret for username. So our secret name is secret store, and the secret key is username, and the secret value is Rohan2101. Let us check if it is uh, injected as a volume for our pod or not. So for that, what we can do, we have two ways. First, we can use print env, where it will print all the environment variables which is attached to this pod. So here you can see that db underscore username underscore 01. We can see this is the value, which is very much similar to the secret value we have provided here. So now let us do some experiment that let us change the value to Rohan12345 and save it. Okay, now let's get exit from this container. Okay, so now let us check again the pod name and let us move. Let's get move inside this pod again and echo the variable which is db underscore username underscore 01. Okay, so it is still showing us the old value for our secret value. So for this, you just have to restart or like terminate your pod. So let us like restart our deployment, which is skate secret. So let me just execute this command, and this is restarted. Now let us check if the pods are running or not. Okay, the new pod is up and running. Let us check by going inside it. kubectl-exec. You can bash. Okay, so now we are inside it. Print env, and we can grep db username 01. So yeah, now we can see that now the value my pod is picking the correct one, which we have just modified, which is Rohan12345, and the same I can see inside my secret manager. So yeah, this was the small demo, like how you can use secret store CSI driver to inject your important or your confidential data as secrets, your keys, your certificates as a volume, inside your pods, and those pod can immediately use those variables or those values. Yeah, I hope this video was helpful, and I was able to explain the use case of secret store CSI driver for your AWS EKS cluster. Thank you, and have a nice day.